Uh, Hello. Please let me know if I am
Hey.
audible. Okay. Please let me
Yes,
know
ma'am.
you are not able to hear me.
Okay.
So we are going to start with SPSS. Some of the pointers in SPSS. First of all, I would like to briefly introduce myself. My name is Dr. Anindita. I teach in Manavashna International Institute of Research and Studies based in Faridabad. And I have been working here for the last 15 years, and I am also placed here as a research director. So today it's a pleasure taking your class, and I have been teaching SPSS and research methodology since last 9 years. So hopefully I'll be able to do justice to my job. I hope we are all ready to get started. Hello?
Yes, ma'am. All set.
Okay, okay. So can you hear me properly, or you are hearing a faded sound? Because I
So we
can
can
hear
hear
you.
you clearly.
Okay, you can hear me clearly. Right. So let me share my PPT before I start. Is my slide visible to everyone?
Yes, ma'am.
Yeah. So first of all, before we start with the SPSS, first of all, it is important for us to know that SPSS is just a tool for enhancing our research output. Okay. So this tool is basically designed to help you to understand how do you take forward your research thing. And a lot of algorithm is already done in SPSS. So for example, just give me a moment. Okay. So basically, what we are going to learn in this session, we are going to learn a bit of variable and hypothesis. Then we are going to proceed with a little bit of scaling and questionnaire design because they are linked. And why I am basically starting it from here is because you will understand that SPSS has got a deep link with the these things, because ultimately, see, SPSS is just a software, it's just an instrument. So still researchers are required to be very much vigilant about what kind of data they are feeding, and on the basis of data they are going to get the output. But generally what happens is, when some other person is evaluating your work, he will go through all those assumptions that you have undertaken before applying any technique. So you need to be very, very sure of what are the assumptions that you are taking, because they are going to justify your result. First of all, one more thing I want to ask, do you want me to speak in English, or you are comfortable, or you want a mix of both Hindi and English? Hello? Hello?
Ma'am, English will do.
English will do. First class, okay. So now, then we are going to understand what is data entry, graphs, reliability test, ANOVA, regression, and factor analysis. So these are going to be the topic which we are going to discuss. And I would really encourage that if you have any issues at any point of time, you can just stop me in between and we can take up your question right there and then. Okay, so I briefly start with a single case study. I hope everybody can see the case study. This is a small case which I have taken as an example in order to make you understand what kind of a situation we happens, and from there how we are supposed to go ahead with doing of the work.
Ma'am, this slide is not moving. We are still on the first slide.
Okay, slide is not moving. Right.
Yeah, now we can see the case study, ma'am.
Okay, good, good. Thank you, ma'am. Thank you so much. So please kindly go through the case, everyone. And on this case, I will base on my analysis through which I am going to teach you certain techniques. So the case says the manager of a Heinz company observes that the morale of employees in her company is low. She thinks that if their working conditions are improved, pay scales are raised, and the vacation benefits are made attractive, the morale will be boosted. She doubts, however, if an increase of pay scales would raise the morale of all employees. Her conjecture is that those that have supplemental incomes will just not be turned on by higher pay, and only those without the side incomes will be happy with increased pay and with the resultant boost of morale. So this is a case. Okay, so this is a real life case where we can see that a manager is facing a problem and he already knows that there are 3-4 things which can be done in order to boost the motivation of the people. So from this, generally research works on a concept of dependent and independent variable. Any variable which we are trying to study becomes the dependent variable, and anything which it is dependent on, that becomes an independent variable, as the word itself indicates. So in the current situation, can you let me know what is independent variable and what is dependent variable? Any one of you? Yeah, can anybody let me know?
Ma'am, the morale of the employees will be the dependent variable,
Okay. Okay.
and the pay scale and the vacation benefit will be the independent ones.
Okay, great. So we go ahead. Now can you see the next slide? Yeah. Is the slide visible to you?
Yes, ma'am.
Yeah, so here you can see that the morale of the employees here, this is dependent variable, and the working conditions, benefits, pay scale is independent variable. Okay, so you can see the arrows are telling you about the direction. Now there is a moderating variable in case of pay scales. So what is that? So I hope you understand what is moderating variable. Moderating variable is a variable that can enhance the relationship, that can affect the relationship between independent and dependent variables. So here it isn't said, and as a conjecture, that the person, those who will have a supplemental income, side income, they will not be that motivated, or they will not have a high morale even after their pay scales are improved. Okay, so from the theory which is mentioned, which is the life problem of the industry, we work towards a framework. Now, this is here what you can see as a framework. Okay. Reaching to this framework, this is also known as conceptual framework. And how do we reach to conceptual framework? That is through our literature review. Once you do a number of literature review, you go through number of dependent and dependent variables, and then you choose yours on the basis of the research gap, identified research gap. So this is a diagrammatic representation of theoretical framework, which is known as a conceptual framework. Now from here, your analysis actually starts. There are few things that you have to consider before you start doing the analysis. Okay. So the first thing is, you have to understand on on what scales are these variables being measured? Which are the scales on which variables are being measured? Can you tell me which are the which of the scales these variables are being measured? So for this, we have to come here. This is somewhat the questionnaire that you have. Okay, the questionnaire which will let you know, like for example, here we come to working conditions. Like for example, here we come to working conditions, and that we use this scale to measure the working condition. I feel deeply connected to the work I do. I am deeply motivated by the mission of the organization. I feel appreciated towards my contribution. And then you can see that there is a scale which is given. I think you can see the slide with the title scales. I hope we are on the same page. A yes and no, please. Hello.
Yes, ma'am, it's clear.
Okay, okay, good. Hello. Yeah. So now we can see the scales which are here. Okay. So generally, how do we define this scale? Can anybody from you let me know that if these are the 4 different scale that we use, this is which scale on which you can see the statement and we can see a strongly agree, disagree is kept here. Which type of scale it is?
Ma'am, it is Likert scale.
It's a Likert scale. Okay. So, yes. It's a Likert scale. Hello. Yes. So now this is, I have received recognition. So this is an interval scale. Okay. Yes.
Ma'am, is there any technical issue or something? Because your voice is lagging in between.
No, now can you hear me clearly? Please let me know if
Yes.
there is a technical issue. Okay.
Yeah, now I can hear you.
Yes, yes, yes. So now.
Excuse me, ma'am. We can't
yes.
see presentation.
Yes. Can you come again, please?
Are you presenting, ma'am, anything?
Are you?
Are you presenting the screen?
Yes, I am presenting a screen.
We can't see anything, madam.
It is visible. It's visible.
Yeah, it is visible. You please check it at your end.
I logged out and I logged in again, ma'am.
Yeah, you can do it again if you want because we others can see. Even I can see.
Okay, okay.
Yeah, ma'am, you can continue.
Okay, okay, okay. Thank you. Thank you so much. Yes. So here we can see scales. So now basically the crux of the whole thing which I was trying to make you understand is this. These are 4 different kind of scales which are used in SPSS. Okay. So SPSS knows these scales, and in fact there are 3 scales only which are used in SPSS. So if I make you see a SPSS data sheet, so you will observe that there is only 3 category scale which is visible. Okay. So this scale is known as a nominal scale, ordinal scale, and the last one is scale. Okay. So I'll just show you my screen. Just give me a minute. I'll just show you one SPSS sheet. Okay, please let me know as soon as you are able to see the sheet. Okay. Yes, I have shared the sheet. Can you see the SPSS sheet?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. So here you can see that in this first thing, just have a look wherever I am highlighting. Okay. So here you can see there's a scale. There is a definition that you have to give in terms of whether it is a scale data, whether it is a ordinal data, or it is a nominal data. Okay. So these are known as scales. Okay, so let us go to the PowerPoint again. I hope we can see the PowerPoint slide again. So here
Yes, ma'am.
is, yes, great. So here is the nominal data, ordinal data, intervals data, and ratio data. So these two data sets are defined differently in SPSS, whereas interval and ratio data sets are defined when we are actually going through 4 different kind of scales. Any idea about what is the reason why? Okay, before we come to then, I hope we are very clear with these 4 different type of data, these 4 different type of scales. Can anybody tell me what is a nominal scale? Any one of you, can you tell me what is nominal scale? You can just try also. Don't fear that you will go wrong. You can always give it a try.
It's more qualitative, ma'am.
Yes, it is qualitative, but this is not enough. Now clearly understand it. Okay, what is nominal scale? Okay, nominal scale is generally qualitative, as ma'am very rightly told, but there is a quality of nominal scale. Nominal scale, it is defined as mutually exclusive and collectively exhaustive. Now, what do you mean by these words? See, generally nominal scale is got a categorical scale. For example, I want to capture gender. So male, female, and there is a third gender. Okay. So what do you mean by a nominal scale? That when you ask this question to a respondent, you will be giving him 3 categories and he has to fit in one of the category. If he comes back and says to you, oh, I am not in these 3 categories, I am in the 4th category, that means the scale that you have made, it is wrong. All the word collectively exhaustive means all the possible variations or all the possible categories that can happen between that variable should be mentioned there. And the mutually exclusive means at one point of time, one person can be a part of one category only. So for example, I ask you your education qualification, right? Your education qualification. So you will say 10th. So I give you option 10th, 12th, graduation, post-graduation, doctorate, any other. Now, if I ask this question in the questionnaire, whosoever is the respondent, he should not be able to say that I am 10th also and I am 12th also. That becomes wrong. If you have completed 10th, then you are 10th. If you have done 12th, then you are 12th. You can't take 10th and 12th together. Your education is the highest degree that you have taken. So that means mutually exclusive. One category is completely different from the other category. And collectively exhaustive means that when I add up all the categories, there should be no option left in the universe to accommodate. For your sample at least, the sample on which you are working. I hope it is clear what is nominal scale, everyone? A yes and no, a quick yes and no.
Yes, ma'am.
Okay, great. Then we come to ordinal scale. Ordinal scales are known as ranking scale. When you give the rank, you use, so at one time, if I ask you which is the quality of drink you like, you might say I like Coke, I like, or if I say you rank in order of your preference, so you might say I've given you 5 options: Coke, Limca, Thumbs Up, Mango Mazza, and Fruity. So you will put 1, 2, 3, 4, 5 on the basis of your preference. So whenever we are wanting to understand the preference, it is known as the ordinal scale. Okay. Here the categories may not be mutually exclusive. And now we come to a third category, third scale, that is known as interval scale. So just now the Likert scale which I was showing you here, this is an example of an interval scale. Why interval scale? Because if you feel the things which are measured in all the statements, you will see it is abstract. So for example, if I ask you, are you thirsty? You say, well, yes. So I ask you, you are how much thirsty? So you can't say that I am like 20 liters thirsty or I am, 1 liter thirsty, because we know that those kind of things have no measurement. Or if I ask you, how motivated are you today in attending this class? You might say, I am very, very excited. And some might say, I am just excited. But these are feelings. Feelings can't be measured in kilogram, centimeter, meter. So research basically converts them into a numerical data. So for this, we develop a data where we give numbers from our side. So now if I have given you 1, 2, 3, 4, 5. So if I ask you, are you able to understand the content which is delivered in the class? So if you say a 1 and the other person says 4, then I know that 4 points there is difference between you and the other person. Otherwise, it was just a feeling. I have tried and converted into a numerical figure. So even you can use a numerical scale which can range from 1 to 10 to have more detailed feeling. So this kind of place where we give the numerical value from our side in order to convert and extract data into a numerical data, this is known as interval scale. Okay. I hope I am clear. Are we on the same page? Hello, are we on the same page?
Yes, ma'am.
Okay,
Yes.
great. See, I am asking you again and again because that gives me assurance that we are, connected. Right. So now the fourth scale is known as the ratio scale. Now, what is the ratio scale? Ratio scale is the strongest scale in the SPSS. I will explain you the reason why. Ratio scale has got an absolute 0. See, if I ask you, can you tell me your age in years? You will have to see, either you tell me 0, either you tell me 1, either you tell me 2. It can't go beyond 0. It can't go into, negative term. In the same way, if I ask you, what's your monthly income? You will say 0 if you are not earning anything. You don't say it's a minus, 1000. That doesn't happen. So ratio scales are open-ended scales in which the value, whatever you will feed, it will definitely have a true 0. It will have absolute 0, which is the problem of interval scale. Interval scale is a value that you are giving. So I can ask you 1, 2, 3, 4, 5, but I may also draft a scale like 0, and on the left hand side, it can be a -1 and -2. It can be 1 and 2. So this -1, 0, 1 and 2, these are just representative figures to make me understand, your feeling. But there is no true 0 in the scale. On the other hand, ratio is a scale which has got a true 0. So if I ask you how many money have you invested in shares, either you say 0 or you say a certain amount of money I have invested. So That is why, because it has got a true zero, it is known as a very important scale. Okay, so I hope we are okay with all the 4 different kind of scales. The nominal scale, the ordinal scale, interval scale, and the ratio scale. Okay. Now, why do I explain you this? I explain you this because when you look at SPSS type of a test, the data which is captured in a nominal and ordinal scale, they will allow you to do only few tests. There are only few tests which can be done on this data. Okay, because this is the categorical data. Whereas the intensity of the test can be increased in the other 2 scale. That is why I told you at the first, SPSS uses 3 scales. So if I show you SPSS, you can see here that we have 3 scales here. Okay, see, there are 3 scales. So the nominal stands for nominal, ordinal stands for ordinal, and scale stands for ratio and interval both. So what is my first bit of advice? If you have a pen and a paper, kindly note it, that whenever you are making a questionnaire, try to collect as much as data you can in the form of interval scale or a ratio scale, because that will allow you to do a lot of mathematical calculation which you will not be able to do of a nominal or ordinal, though I agree with the fact that few variables can be only evaluated on the nominal scale. Now you will ask me, ma'am, what do you mean by that? So for example, I'll just show you a questionnaire. Okay, I'll show you a questionnaire, demo questionnaire. So just have a look at a demo questionnaire. I hope everybody can see the demo questionnaire. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. So here you can see the first thing, a variable which I have measured is known as name. This second variable which I've measured is known as age. So you can see that I have created a category of age, like 15 to 20 years, 21 to 25 years, then 25 to 30, then 30 to 35. And you can see these are categories. So this scale actually is a nominal scale, because if I want to enter the age, then I would have to take on one of the category. But the thing that I especially told you, before coming on to this example was that always try to collect maximum data through ratio scale. So if I wanted to collect the same data through a ratio scale, I would type age and I would type dash and I would type years. Okay. So this becomes a ratio scale immediately. Why ratio scale? Because you have to put exact number, and answer can be only in a form of a number. It can't be in a form of a string. And the value of that number cannot go below 0. 0 has to be the last number there. So anybody is 24, 25, but 0 is the first count. So automatically now age becomes a nominal. From the nominal variable scale, it becomes as a ratio scale. So this is what I exactly meant when I told that you should always collect your data via a ratio scale till the time it is possible. Because see, generally also when you have this kind of data, you can easily come to a nominal data. You can create the categories and you can do a frequency count in the categories and you'll get your questionnaire. But if you collect the data in this kind of a categorical scale, it will be very hard for you to get to the exact respondent's exact age if you want to do a more detailed analysis. So it will create a burden, it will create a block there. I hope you have understood my point, what point I was trying to make through. Can anybody answer? The thing that I just taught? So I'm going to conclude again. I was teaching you different type of scales because defining of scales is very important in SPSS. It affects your analysis. SPSS have generally 3 scales: nominal, ordinal, and interval. And I just explained you basic nature of all the different kind of scales. Though in real research, we have one more scale that is known as ratio. That is the interval and the ratio are combined in SPSS as a scale data. Okay. So we did try to understand that whenever we do an analysis part, or we are trying to collect some data from the respondent, we should always do it in the form of a ratio scale till the time it's possible. I hope we are on the same page.
Yes, ma'am.
Yes, ma'am.
Okay, great. So now I go to the next portion, that when I tell you this thing, so what are the different type of tests that can be applied on ratio, which can't be applied on an interval scale? Because scales in interval scale is a very, very strong scale. So you'll be very surprised to know that all the good tests, can anybody name some different kind of tests? Any one of you?
Chi-square,
Chi-square
ANOVA.
test, yes,
ANOVA.
yes, ANOVA.
T-test.
So yeah,
T-test.
so we start from the basic test, the measures of central tendency. So what are the measures of central tendency?
Mean, median, mode.
Mean, mode, median, right? So in a nominal scale data, you can start from mean, mode, median. You can do a chi-square, and you can do that much only. That much only it allows. What it allows? Mean, mode, median, and the chi-square. Apart from this, you can't apply more tests to it. You can just make graphs out of it in the analysis. Whereas in the ordinal scale, it is another type of qualitative scale. You can use median, you can use the dispersion, variance, correlation, those things you can do. Not more than that. Basic tests. Basic test also not. They are just, representation to understand the data in a finer way. But immediately when your data is in interval or a ratio scale, you can use standard deviation, you can use variance, you can use, you can use a t-test, you can use ANOVA test, you can use f-test. So all kind of tests you can use in interval or ratio scale, which SPSS recognizes as scale. I hope till this point we are clear. Why should we very vigilant? We should be very vigilant from the time and point when we are making a questionnaire. That is very, very important. Okay. Now we move to the next slide. I hope we are clear till now, students, or it's all clear.
Yes, ma'am.
Okay. I hope you are able to understand, or you want to give me any feedback. I hope we are going good.
Yes, ma'am.
Yes,
Yeah.
ma'am.
So can you see the slide which I am, so from here we start the data analysis. So data analysis, first of all, I will try to show with this flow chart. I hope everybody is able to see the flow chart. So
Yes.
yeah, so on the left hand side, you can see data collection. And from after collecting the data, we have to prepare the data for analysis. What do we mean by analysis? That means we have to edit the data. We have to handle the blank responses. We have to
Ma'am, can I
code the...
interrupt you?
Yes, please.
Hello.
Yeah,
Ma'am,
I can
if
hear
you
you.
don't mind, can you remove that slide sharing things, either hide or it's coming in between the slides?
This
That slide
thing.
sharing. Yes.
So should I stop it?
No, ma'am, if you can hide it, so it won't
Yeah.
come in between the slides.
Yeah. Is it clear now? Is it gone now from your end?
Yes,
Yes,
ma'am.
ma'am.
I have
Yes,
removed
ma'am.
it. Okay, okay,
Thank you, ma'am.
fantastic. Thank you for the feedback. Yeah. So now you can see here that editing of the data, handling of the blank response, coding of the data, categorizing data, creating a data file, and programming. These are known as the steps by which you prepare the data for analysis. We will just go through it in a live way. Then you proceed towards data analysis once you have cleared the form. So there are three different type of things that we do. First of all, we do a feel for the data by using mean, standard deviation, correlation, frequency. So that will tell you more about data. Mean, mode, median basically explains you the spread of the data. That data starts from where, ends where, what is the mean and median, what is the mean of the data, what is the median of the data, okay? And it also explain you whether the data is from a consistent type of a sample or a sample is widely varied, okay? So in those cases, the variance will be high. So you will get a proper feel of the data. So you might collect opinion on is smoking good for health. You might get a very variant data. Some people will say yes, some people will say no, a big no. So you will get a feel of the data. If all the population has got a consistent answer, or they have got or their answers varies widely, because those all things you will have to write down when you write your explanation in your analysis after you make report to explain your analysis. Then another important thing that you have to do whenever you do a questionnaire, especially whenever you are using primary data for analysis, you have to prove the reliability and the validity of the data. Okay, it's very, very important. And the last thing is that you can do any hypothesis testing to test the data and to give the interpretation. So this is in short whatever we do before we start interpreting the result. So now we first come to a SPSS sheet to understand what is a data. Okay. So I will take you to the SPSS sheet, and at the same time I will show you a questionnaire. So this is a questionnaire. Okay. So this is a questionnaire which we circulated among the people in order to collect few responses. So whenever the data comes like this, what we do is that first of all, we code the questionnaire. So I will allocate a number 1. So if I have say 500 questionnaire, from my side, all the 500 will have a serial number. So they mention actually the respondent 1. So what is the advantage of doing that? Generally, when this kind of questionnaire comes, what we do is that we convert it into an Excel. So you can see that here is an Excel. Can everybody see my Excel sheet? I hope yes.
Yes, ma'am.
Yes. So
Yes.
you can see here that people have answered. So this is the answer in 1. So the first respondent is my serial number 1. He has answered gender as 1, age as 3. So we'll go to the questionnaire. So gender as 1 means he is a male. Age as 3, that means he is from 30 to 35 years of age. Okay. And then he has given all the details, right? So this is an Excel sheet that I have. But SPSS will have a different kind of sheet. Now I will show you what sheet I made out of this Excel sheet. So Excel sheet is the first beginning of the data. So if you see my serial number of the Excel sheet, it goes up to, you can see here, it goes up to 102 respondents, right? So that means my people sample who filled up the, who volunteered for the questionnaire, they were 102 people who filled this questionnaire. Okay. So 102 rows means 102 questionnaires I have in hard copy or I have collected through online circulation. So now I take this sheet and I do a cut copy paste of the same in my. So this is an SPSS sheet. I hope the SPSS sheet is visible to all. Okay.
Yes, ma'am.
So SPSS sheet says, you can see here, it has got two views. One is a data view and one is a variable view. Am I clear? Data view and variable view. So the first sheet is known as a variable view. Variable view is simply means that each of the question is your variable, and whatever calculation you want to do, you are going to do it on the variable. See, calculation will always happen on the variable. It will not happen on the constant. Why do we say so? Because variable changes value. So for you it may be a 2, for me it may be a 5, my job satisfaction level. Okay. So you can see, if this is my questionnaire, I have converted this into SPSS variable view sheet where I have defined age, gender, education, city, and then we start with the main analysis thing. Now, let us understand the fields in the SPSS. If you go to now, this is known as name. Name is just a representative thing. So you can't use any special, characters, or you can't use a space, and there is a limitation of the length. So you can see, marital status, I have used an underscore, or I have used, preferably, if I make you see the preferable mode. And the whole explanation of the statement you can write here. So if somebody is confused that what do you mean by preferable mode, so I will go to our questionnaire and I'll try to search for the question, So if you say this is language spoken varietal status, so I'm going to, cut copy, the preferable mode, this is the question. So I can just do a cut copy paste and I can put it in my SPSS, so that if there are a group of people who are working here, they will be able to use this. Oh, it's so we have to type it. Okay, so you can write explanation of this, so that any other person who is handling your sheet, he can understand what questions are you trying to ask, right? So this is width. Width is, I think it's very much understandable. These are the decimal places. So generally leaving from the money thing, otherwise generally we have decimal places depending on the variable that we are using. Now it's very, very important is defining the values, value labels. So in this value labels, you can actually understand 1, 2, 3, 4 stands for what, right? Because if you see my Excel sheet, you can see that the age is entered in 1, 2, 1, 2 in this form, in the numerical form. So it's very difficult for anybody to understand what one means by you. So what happens in SPSS, we have to tell him what ones means. So here is a value label we create. So like for example 1, or say if I type 6, so I'll say nothing. So it understands 6 is nothing. Or for example, if I say 99, and I write here it is representing my missing data, right? So you can create. So basically what I'm trying to understand, whatever the categories that you create, you have to define here. So here you can see my questionnaire options. I have made 1, 2, 3, 4, 5, and 5 is 40 years old. Okay. So that is I have defined. Now, what do you mean by missing? Now, missing data is very, very important, because just tell me one example. If see you are handling a questionnaire and you see that some person out of 10 questions, he has answered only 8 questions. 2 questions is left. So how do you handle the data then? You tell me, how do you go about it? Do you reject the entire questionnaire, or you put something from your side into it?
Ma'am,
So what do
we
you do?
supposed to put something from our side.
That is wrong. Never ever do that. Okay, because SPSS gives you a facility that if few people have not answered, because see, generally if you put anything from your side, it will be your bias towards the situation. And that will affect the real output of the data. So SPSS allows you a provision that for those variables in which, so for example, your total sample size is 102, and say 2 people have not marked age. So I am going to put a missing data on this. So what happens when the SPSS do the calculations? What will it do? Whenever it takes the age as any numerical figure and it considers its mean, mode, median for an analysis, it will only consider it out of 100. Whereas your original sample size is 102. Because if you mark from your end, it will create a disturbance. Okay. So that is why we use a missing data function. So instead of rejecting the entire questionnaire, which initially people used to do, or some people also will recommend go back to the respondent again, try to have contact details and reach him. That is going to be a tedious process. If you can do it, it is very well and good. But otherwise, you use a provision of missing data analysis. So those two columns, so that is why in variable view, you have to define what do we mean by missing data. So I'll open this. So yes, see, there is no missing value. If there is no missing value, 102 responses you have got on that question. If you have a missing data, you just write 99. So what happens anywhere from this option? These are the standard options which I've already told to SPSS. If other than this option there is a 99, then that means that this is a missing data. Am I clear? Am I clear? Till now. So if I show you the variable sheet, if I show you the data sheet, so if I write 99 here, so automatically SPSS know that this is a missing data, and whatever calculations of age I have to do, mean, mode, median, whatever I have to do, I have to do it using missing data. Okay. I hope it is clear. Yes, no.
Yes, ma'am.
Okay. I hope we are clear till now and there is no confusion. Okay, so we go to
Yes.
variable data. Yes, anything?
Ma'am, can you
Hello?
explain 99 thing again?
Yeah, I'll definitely explain you. See, 99, don't take it as 99. It is my representation of missing data. I can also put 72 here. So you have to understand the concept. So yeah, I can put 72 here, right? But why do we do this? Generally, we tell you keep one numeral. You can use 10, you can use 15, but generally 99, it will stand, it will stand as very clear. So you will not have any confusion. Generally, what is 99? 99 is a number which I have chosen in order to represent my missing data. So generally what happens is whenever we are putting in the data of the questionnaire into a SPSS sheet, we come across many such questions which have not been answered by the respondent. So in that case, generally some people from their side, they are going to put the data, they are going to mark the data. Some people will not, some people will reject the entire questionnaire. So SPSS gives you a provision that for those variables for which the respondent have not answered, you can put them under the category of missing data. So for example, these are the options which in standard way a respondent was required to choose one of the option, but he did not and he left the question. So in those cases, when I am entering the sheet, I am going to put a missing data representation. So 99 means missing data. Okay. So what is the advantage of this kind of a provision of SPSS is that there is no data loss. So if that person has filled up 70% of the questionnaire, there is no data loss. You can use the 70% of data for analysis, but for those 30% of the fields in which he has not entered any data, you can leave it from analysis. So when you put a missing data, a number, that number should be defined here as a missing data. So what happens when you are putting your data sheet and say for the respondent number 4, I put age as 99. So immediately I also know that this person has not opted this field, and you also know, and the SPSS software also know that whenever I do any calculation of age, I will have to quit this data field. So generally, if I am doing a calculation on 102 data set, for this category, I will do a calculation of only 101 data set. Am I clear, ma'am? Have I
Yes.
answered your question?
Yes, ma'am. Thank you.
Okay,
Actually,
okay.
my network is weak, no, so I missed the part last time, so I asked you to explain. Thank you,
Okay,
ma'am.
okay, my pleasure. So these are the known as missing data, and then there is a column, there is alignment, and then this is very important. This is the scale definition. Okay. So earlier SPSS versions used to end heel. So for example, age, because here I can see that age is my variable which I have asked in number of categories. So I am going to define it as the nominal data. Okay. In this way, for all the questions you have to define. You can see I have put a nominal here, and then I have finally put scale data. Now this is a new feature which is being introduced, in which you can define much more, but generally we keep it to the input or the both. Okay. So role, this is not very important. You can keep it as a none also for a neutral view. So that is absolutely fine. This is a new thing which has been introduced till 20th version of SPSS, version 2.0. There was no certain field. So anyway, this is your variable view. I hope we are clear with the variable view. So if I take you more through the variable view, you can see for gender, the categories are 1, 2, and 3. 1 for male, 2 for female, 3 for transgender. And if somebody puts a 99, that is a missing data. That person has not filled up the thing. Then for marital status, 1, 2, 3. Okay. For the language, Hindi, English, and others. These categories I have created. Okay. And then you can see an interval scale. I have clearly defined 1, 2, 3, 4, 5. 1 for strongly agree, 2 for agree, 3 for neutral, 4 for disagree, and 5 for strongly disagree. I hope we are clear. With this, we finish with our variable view sheet, and we go to our data view sheet. Data view sheet is just an Excel sheet, but on the top range here, you can see all the variables coming. Whatever variable you will define here, it will be visible here, and your sheet will be complete or prepared for the analysis. So this is the way in which we prepare our sheet for analysis, right? Now I will just show you one functionality of missing data before we proceed. Okay. Okay, just give me a moment. Yeah. Okay, so we move to our slides again. Now there is one more thing which I want to show you, that is known as ordinal data. Okay. Now this is again very important. When I teach you this, I take you to a slide here, which is this. This is a framework that we have established in which we know working conditions, benefit, pay scales, these are the job satisfaction, these are various things which will increase the morale of the employees. So we are trying to capture this. Okay. Now it is very important to understand in which different ways the data is being captured. Okay. Why? Because this is your dependent variable and this is your independent variable. Any SPSS test or any statistical test, let's not talk about SPSS. Any statistical test that you apply, it is very, very important that you have to define the scales in that. If you are not able to define the scales, it will your test is going to go wrong. So I'll take you to this table now. I hope everybody can see the table.
No,
Yes
ma'am.
or no? Hello?
Yes, yes.
Yes. So now you can see this table. You have to remember. This table is widely available on internet. Or you have to keep in mind that I have to always understand which are the scales on which the data is collected for the dependent variable and independent variable, because that will allow me to choose a test. So here you can see on the x-axis on the top, there is dependent variable. I have written in the green, and on the y-axis, there are the independent variable. So if your dependent variable is also nominal scale and your independent variable is also nominal scale, if both the different type of variables, so that means, say if I have collected the pay scales data and I have collected the satisfaction data, and both are categorical scale, then I am going to put a chi-square analysis, right? If my independent variable is a nominal data and my dependent variable is an interval data, then I am going to use analysis of variance, that is ANOVA. Okay. If my independent variable is interval and my dependent variable is a nominal, then I am going to again use analysis of variance. If both of my variables are in interval or ratio scale, my dependent and independent, I am going to use a regression model. Are we clear about this table?
Ma'am, I have a doubt.
Yes?
We clear it?
Yes?
Ma'am, if both my data are interval, that is on scale, and they're not normally distributed, what do I do?
See, if it is not normally distributed, then first you have to perform a test of normality.
Yeah, they're not
Okay?
normally distributed, say.
Yes, if they are not normally distributed, but there is statistical test by which you can prove, which I have in the slide, I'll show you. Otherwise, generally we have a parametric and a parametric category of test. I hope
Yes.
everybody is aware of it.
Yes, ma'am, we are aware.
Yes, there is a parametric and non-parametric category of test. So parametric category of test, it assumes that the data is normally distributed. Yes.
Right, ma'am.
Okay. So
Yes,
every data that you do, see, generally, if I'll tell you it, I had a live experience of this. My scholar, once he did a data on, I think he did a uh, he did an analysis based on parametric test where when the examiner came, he pointed out that I don't think the data is, because the mean mode and median that you are showing, It is
Huh.
showing that there is certain amount of skewness in the data. Okay, ma'am?
Yes.
So
Yes,
he
ma'am.
pointed out this thing very, very immaculately. He told that please don't use the parametric category of test. You use a non-parametric category of test. So
Yes, ma'am.
the reason that he was giving is that you will still find the value will come same. But if anybody external is checking, you know, the process wise, you will not be at fault.
Right.
Or you do a test of normality. There is a Shapiro test and the Levins test. You do it, and if you're getting the count in that, that is also enough to explain that that your data is fine. Okay, so we'll just come on to, so basic thing that I'm trying to make you understand is whenever you are thinking of an analysis, try to first understand on which type of scale the data has been collected, because that is going to affect the choice of scale. So I'll just give an example. See if anybody else is having any issue, because now we are going to core concepts. So you have to tell me, you have to stop me and you have to tell me, ma'am, we have not understood it.
Ma'am,
Okay?
could you answer that question?
Yes,
If
ma'am.
both the independent and dependent are uh, uh, interval data that is on Likert scale and they are not normally distributed, what test would you suggest? Non-parametric test.
They are not normally distributed.
Yes, ma'am.
I think then we will not go by regression anymore. We have to do the ANOVA in a breaking form, for each variable. Regression is basically, it's an ANOVA which happens together. So in
Right.
that case, we will have to do either your Krusell-Wallis test or a
Okay.
Friedman test. Okay.
Okay, ma'am. Thank you.
I'll just go through it. So we come here to this data. Right. So first of all thing, where you start the analysis is when I come to this thing, what are different type of scales? So I'll just take you to this hypothesis. Working condition has a significant impact on the morale of employees. Now here we can see that the working condition would be something of interval scale, because the person would have told his heart feelings. Is it good? It is bad? It is how satisfied is he with the furniture? How satisfied he is with the quality of work? How satisfied is he with the extended hours of work? So that will all represent the working condition, but it is his satisfaction level. So we know that it is a scale data as per our SPSS, and then we go with a morale of employees. Okay. So since the data both are in interval scale, then we know that we have to choose a test accordingly. So quickly we are going to refer to this chart and we are going to find which scale is it. So here we find that it is regression analysis. Okay. So this is how we go about it. Now we come to the first thing that you do in SPSS. The first thing that you do in SPSS with the variables is that you are going to use charts to make the person understand about your data, and you are going to use a set of descriptives. Am I clear? You are going to use a set of descriptive to explain the data. Okay. So how do we use that? I'll just show you. Okay, I think there is some issue with the SPSS thing. So generally, if I show you the SPSS version, there is a menu on the top end of the corner. I don't know why it is coming on this laptop. Just give me a moment. Just allow me some time to check it. Where is the error coming? Hello, ma'am. I'm joining from another laptop. Kindly allow me, okay? Because the SPSS sheet, I think there is some problem in the
Yes.
SPSS sheet. Okay?
Yes, ma'am. Sure, sure.
Yeah. Hello, ma'am. Can you hear me?
Yes, ma'am.
Okay, great. So I'll just share my screen. Yeah, can you see my screen, everyone?
Yes, ma'am. It's visible.
Okay. So now I bring you back to the sheet again. So here you can see. See, why did I switch off from another computer? Because these menus, these play an important role in executing the commands. So if I take you from there, so whenever you want to make, so first of all, we are going to take, for example, we are going to go to analyze, we are going to go to the descriptive statistics, and we are going to the frequencies. Okay. So we are going to say choose the data, the demo. You see, generally the data which is demographic or which is qualitative in nature, you can't do very much from it. You can just explain, theoretically the qualities of your sample, because when you do the final analysis, you can correlate both the facts. Okay, so I take age, gender, education, and I shift it to the variable category. Okay, then I go to statistics. And here you can say what kind of data would you want in order to make the data more readable. Okay. So variance, and then I continue. And then it also asks you, do you want to make any chart? Okay. So I say bar chart. Now, do you want to put a frequency or percentage? Similarly, for a pie chart, it will also ask you, do you want to keep the frequency or percentage? So you have to select, and then you press OK. So now it is generating the output. So we can see the output here. Yes. Now can you see the output on my screen? So it has given, yes, it has given you all the three variables. It has given you the explanation of mean, a median, okay. So mean can also take in view of outliers. So for many people, they only consider median. So whenever if we, in education industry, whenever the student comes for admission, he will ask, what is your median salary? Median salary is what is the maximum number of salary, what is the midpoint in terms of maximum number of salary that a person has drawn. Because mean can give you a different impression. Okay. So then for each of the variables, you can see the categories here. So in this data, only one person out of 102 is of 25 to 30 years category. Otherwise, all are from 15 to 20 years of category. If I talk of gender, now see, here is an error coming. What is this error? It is taking 36 are females, 52 are transgender. So that means there is some error that has happened in defining the variables. So we will go to the variable sheet just now and we'll try to find out where is the error. So this is the gender that we have used. Okay. Now we go to the variable view and we try to take care of gender. So here it is written 1, 2, and 3. We have three categories only. But in data view, if you can see, there is a 4 category also, right? So this is a wrong data which is being entered. Okay. And then you can see there are some question marks also. Okay. So that means this data, there is some problem with this data and your data is not fit. Now there is a category 5 also. There is a category 6 also. So that means whosoever has entered this data has been entered wrongly. Right? So we can just look at the output, because in output, if according to our questionnaire, so if according to our demo questionnaire, uh, the data has got only 4 categories or 3 categories, how is this 4th category coming? So in gender we have 3 categories only. So that means there has been some issue at the angle of data entry operator, the person who has entered data for you. Okay. Or the person who has entered the data, maybe if you have collected it online and Excel sheet is auto generated, then that person has filled it wrongly. Then you have to put all this extra category in number 99. They are all your missing data now. Okay. So what I do is I go here and I edit the data and I make it 99. Only I will have either answer for 1, 2, or 3 or 99 directly. 99 means that it is a wrong data which is entered, so it will not be calculated in the calculation. So let us see if I do 299s. Okay, and if you see here, age is defined, gender is defined, a missing data is defined for gender. So now when I do the analysis of frequency, okay, and I do okay again, and I go to the gender again, you see automatically, since 2 entries I change, it has given a new category, that is a missing data. So it is saying 3 data is missing. So the analysis was carried only out of the 99 right data which is there. I hope the concept is clear to everyone. Yes or no?
Yes, ma'am.
Okay, great. Okay, now we proceed to the next level of analysis that is known as, I hope my screen is visible to everyone.
Yes, ma'am.
So this is a bar graph, you know, there are scatter plots, there are, population graphs. So as per your requirement of a particular data field or data area, so for example, if you have done something related to area, okay, then you do it accordingly, okay. So this is parametric and parametric test, and now test of normality. So generally this Shapiro-Wills test, this helps you to test the normality in the size where sample size is less than 50, but it can also handle the sample size as big as 2000. So this is really for checking out to which category of data my data belongs and how do I go for it. So this is the category. Now you will be wondering that how do I know what are the cables and where, which test. So basically what we are telling you in this session is that everything is on Google, everything is online. We are just trying to create an awareness. We also understand that, see, now there are a lot of software. There is SPSS, there is MOS. There are a number of software which we use. There is R, programming in R through which you do, or you do calculations from Excel. So it is not possible for a human mind to remember all the steps every time. But these basic fundamentals which I am teaching you related to scaling, related to questionnaire development, there is a concept of handling the missing data. There is a concept of parametric and non-parametric test. That whole thing you have to tell us. Okay, that you should be very clear, because those are the basic things, those are the building blocks. That has nothing to do with the software. So if your research is defined well on those criteria, then you will have no problem. Okay, so we start with first test. I think first test which I'll do with you, let us do ANOVA. Okay, so let us go to this Shapiro-Wills test. So I'll just see, I've pasted a URL here. I'll take you to this URL and you will understand that how easy it is for everyone. See, now there is a complete theory that is here. Can everybody see my screen? Yes or no?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Okay, great. So you can see there is a website called as the statistics by liar.com. So it is testing for normality for SPSS statistics. So you just read here, an assessment of normality is a prerequisite for many statistical tests because normal data is an underlying assumption of parametric testing. The two main methods are graphically and numerically. So this teaches you to do it numerically. So what it will tell you is that you will have to go. So we'll just take the steps and we'll do it. Okay. So I'll open my SPSS form. So I go to analyze. Okay. Then what we see here is analyze, descriptive statistics, explore. Okay. So this is the thing I have selected. And then the second step, it will tell you, now you have to choose which data set you want to see, whether it's normal or not. So this is a dependent and this is an independent. Okay. So here you can see they have put the time as an interval data, which is dependent, and course as a factor data. So let's do the same on our file also. So we have a gender is our independent. Let us take education as independent, and let us take our first variable from where interval scale starts as dependent. Okay. Then what do we see here? Then once you fill up the data, you have to go to the statistics tab here and you have to click descriptives and you have to see whether 95% is defined or not. We'll do the same. We'll go to statistics. So 95% is defined. We have checked. Okay. And then we do okay. Okay. No, there is some issue. Just give me a minute. Descriptive, stem and a leaf plot. Okay, normality plot we have skipped. We should have done explore plots, normality and stem factors level together. So we'll just try it again. We'll go to analyze, we'll go to descriptive, we'll go to explore, we'll go to plots. Okay, so normality plots, this we have to click. And then we do continue. Okay. So this entire data it has given to you. So there is a way in which we read the normality plots. So we'll go here. Now it will show you the output of the data too. So this is the table that they will show you. We'll just go to our slide. Okay. So just to understand the example, they have done this research study on a manager who wants to increase the speed of the particular spreadsheet program. So they are offering a 3 course, a beginner, intermediate and advanced. He is unsure which course is needed to do at his company. So he sent 10 employee for beginners, 10 employee for intermediate and 10 employee for advanced. So for that he does a one-way ANOVA. Okay. And when he does one-way ANOVA, you will see that he has selected the data. And then these are the post hoc comparison. Anybody can tell me what do we mean by post hoc comparison? Anybody? Yes. What is a post hoc comparison? Any idea of ANOVA? Are you aware of ANOVA? Hello?
Ma'am, is it a comparison of means?
It's a comparison of means, yes. Okay, so post hoc basically will tell you whether, see, if a hypothesis, it is very much clear that there is a, in the hypothesis, it is clear that there is an issue. Okay, then that there is a significance level that is already proved. For example, there is two genders, male or female, and you find that there is a significant impact of gender on job satisfaction. Now the second question that will come in mind of anybody is that I want to know which gender, okay, whether it is male or whether it is female. Then in that case, for that certainty, we need to do a post hoc analysis. Okay, so in the post hoc tab, when you click, you have to choose Tucky, and significance level is 0.05. Okay, after that what you do is, when you click to the output, then this output is going to come. Okay, now can anybody help me to understand the output? Anybody who is aware of it? So the question that we've had is that the manager has sent 10 people for beginners course, 10 people for intermediate and 10 people for advanced course. And he want to know whether it has got any effect on their, on their mean length of time in which they solve a, spreadsheet. This was about that. So the beginner, intermediate and advanced were your nominal scale data, and the efficiency was an interval scale data. Okay, the length. So this is the output. Now in this output, if you see clearly, this first table, it basically explains you the descriptive of the thing. You can see the mean of the 10 people. Okay, and total is 30 people. So 10 people have gone. Okay, So you can explain it in theory that 10 people went. In the beginners, this is that. But in the ANOVA table, if you see, in the ANOVA table, the level is 0.021. So 0.021 means, see, SPSS doesn't understand. In statistics, we have a chart, we go behind, we see the degrees of freedom, and then we check from the scores whether it is significant or not. But in SPSS, you have a relief. The test of significance is 0.05. So if you check the level of significance and it is below 0.05, that means there is a significant difference. So hypothesis that we are following is that there is a significant impact on the type of training you have received on your ability to solve the problem. So here it says that there is a significant difference. Now the second question which will come to your mind is, which one? Is it the beginner's course? Is it the intermediate course, or it is the advanced course which is making a difference? So for that reason, we have clicked there the post hoc details. So when you click the post hoc details, the output is going to be like this. Okay. So now in output, this is again what you are supposed to see. 0.046 and 0.034. For intermediate, if you see intermediate to advanced, there is no significant difference. But between beginner and intermediate, there is a significant difference. Okay. Here also you see between advanced and beginner, there is a significant difference. Okay. So on the basis of this thing, we will be able to claim on the basis of mean scores of these three that advanced and intermediate are making a definite difference in the length of time in which he is able to solve the spreadsheet issues. Am I clear? Or I should repeat the example again?
Ma'am, it's clear.
Hello? It's clear?
Yes.
Okay. Yeah. So this is ANOVA test, which will help you to understand that if you have three categories in the nominal scale, and that is having some difference on an interval scale variable, because that is the condition in which we can use analysis of variance. Okay. Your one of the scale should be interval and the other scale should be categorical. Okay. So from that you come to know that this is the correlation which is going to give us the complete detail that which of this will tell. ANOVA table is going to tell whether it is significant. See, if it is not significant, so the analysis stops here only. But if it is significant, we'll go further, and then this is the way in which you write the issue. Now you will be again wondering that how do I understand, how do I write it? Because few of our PhD scholars also, they face a problem. So again, this written statement also you can find online very much, that how do you report a result and which are the significant things that you should be reporting. So this is same language that you have to use in order to report whatever you have derived, followed by a normal explanation of the theory. Because this is a statistical test, theory, to connect it with the theory that you have to do as a researcher. So with this, we stop with the ANOVA, right? Do you have any questions about ANOVA? Yeah, any questions? Anyone?
No, ma'am.
Can I move ahead?
Yes, ma'am.
Okay. So now I have another test which is known as independent sample t-test. Okay. Now, what do you mean by independent sample t-test? Any idea what do we mean by t-test? Any idea? So any test you apply, so independent t-test is basically Independent t-test is basically you have a dependent variable which is measured on an interval or a ratio scale, and independent variable should be measured on categorical scale, or it should have two independent groups. Okay, right? Now, what do we mean by this? So we mean, now one beautiful thing about t-test is that t-test can be applied on a sample which is less than 30 also, because it is kind of treated as a non-parametric test. Okay. So ANOVA, if statistically you go ahead, they will say that minimum you should have a 50, because generally when we talk about normal distribution, some people assume that if the sample size is over 50, you can do a test of normality and you can use the t-test, you can use ANOVA. But t-test you can do even if your sample size is smaller than that. Okay. So here we are doing a t-test where we are doing an independent sample t-test. Now see, there are two categories of t-test. One is an independent sample and one is a paired sample. Anybody has idea what is the difference between these two? Independent sample and paired sample? I don't know whether you know that. There are basically experimental designs that we do. Experimental designs, in which we have a control group and we have experimental group. Okay, so in the cases where both are our experimental group, so basically, we can say that we have developed a medicine about headache, and we have two samples of 30 each, and to one category we give the real medicine, and to other category we give a small same, which looks similar to the medicine, but it is not a medicine, it is a kind of a chocolate. So after that we want to see the result. So what I basically wanted to tell you, these are two samples which are independent. If I want to do this test in a different way, and if I have only one sample at my hand, and I do a pre-test and then I do a post-test, okay, then that kind of a test in which your sample remains same, and there is, so that is known as paired sample t-test, because the sample remains the same. What is the pre-effect, and then we give the treatment, and then we measure the output. Okay, so we want to check the awareness of people about the social media. We take a pre-test, then during the experiment we consciously expose them to certain experiments, and then we collect the data after the post test, and then we compare the result of pre and post to really understand that how much the training on social media we gave to them that made a real time difference, because we have taken the assumption that already people are using a lot of social media, so many people are aware of it. So we really want to know what is the efficiency level of the training that we give. So that kind of a study when you do, where the sample remains the same, it becomes a paired sample t-test. Am I clear about that? Yes or no? Please let me know. Hello, yes or no? I hope I'm audible.
Yes, ma'am.
Oh, thank God. I thought I got disconnected. Anyway. So again, what do we do here is, we go to this, so here we are taking a study, okay, where we are giving a treatment for reducing the cholesterol. So we have 30 respondents each. We have given the name 1, and to the another group we give them certain exercise to reduce the cholesterol. Now we want to know which of the treatment that we gave, are both the treatments significant or not? If yes, which one? Okay, this is the question we are trying to solve. So the codes that you have to remember is analyze, compare means, independent sample t-test. Okay, this is the code that you have to remember. Okay, analyze, compare means, independent sample t-test. Then what you do here, so the test variable is your cholesterol. Now observe, here is a scale data representation. So this is a requirement that the dependent variable should be a scale data. And the grouping variable, so they want you to define the grouping variable. So group 1 is for exercise, sorry, group 1 is for diet and group 2 is for exercise. And then 95% continue, and then you get this output. When you get this output, the first thing that you have to see is the mean and the standard deviation. So when we try to reduce it by diet, the mean is significantly higher, whereas when you do it by exercise, the mean is lower. Okay, that is the first observation that you see. Now we see the answer of t-test. Now the t-test, we have to see again two-tailed test. Now you see here automatically they are giving you a Levin's test also, which is actually failing. Okay, so significant test, it shows that 0.20. So 0.02 is less than 0.05, which is our level of significance. Okay, that means that there is a difference. There is a difference which is happening, but we want to know which is making a difference. So then we see the mean, and here we see that the exercise is creating, the mean is going less. That means exercise is creating more difference in comparison to the diet. So this is how we will report the result. This study found that the overflow physically inactive male pay participants has statistically significant lower concentrations. Okay, at the end of the exercise training program compared to a calorie controlled diet, this was the output. Okay, so this is the output of independent sample t-test, which you will use under such cases. I hope we are clear with independent sample t-test. Yes or no? Hello, are we clear? Can I proceed?
Yes. Yes, ma'am.
Yeah, thank you so much. Thank you so much. Okay, paired sample t-test, as I told you, will be on a similar sample, and the quotations and the commands in SPSS will be compare means, paired sample t-test. Okay, and this is going to give you this kind of a result. Again, you will see the result, it is significant or not significant. So here it is clear that whatever things you are doing pre and post of a sample, it is creating a difference. That means if I am talking about the training on social media that I am giving to my clients, so I have done a pre-test, then I gave them some training, and then I do a post test. And if my result is coming 0.045, this is less than 0.05, that means yes, the training is making a substantial difference in the level of understanding. So this will be a data which I can show to my management or their management to tell that yes, the training that I am imparting is really creating a difference in their mindset. Am I clear? This is known as paired sample t-test. So what I want to tell is that you only have to decide the test on the basis of assumptions that I have taught you. And assumptions also completely, how to, where to start from. Okay, initially, when you plan making of the questionnaire, from that phase only you have to plan your analysis well, right? From making of the questionnaire only, your data analysis plan would be well defined. Then, because ultimately, if you collect the questionnaire once and then you feel, oh, then this data is wrong, or I could have collected in this, or this should be an additional data, then you will have no option of going back. So that is why whenever you draw a questionnaire, from that phase only be very vigilant. When you give scaling to your things, you should use nominal scale, independent scale, all those things should be well sort out whether you are using a parametric test or you're non-parametric test. And a lot of literature, especially SPSS from IBM itself and Lilad, they all have a lot of software on the Google which gives you a brief about it. You know, I just opened the sheet and I just showed you. They will have they have given snapshots, and on the basis of they will give an analysis to you. Okay. Now I will tell you one more problem that people face. It might happen that when you do some analysis for your data, it may see, because generally when we take up examples through via, you know, to teach you, we take you very ideal examples which give you clear cut instructions. But generally in real life, the results don't come out in that clear cut way. Okay. So under that reasons, you have to under that situation, you have to understand that you have to go back and check your data. And that is why I'm again and again telling, the editing starts at the scaling level only. When you are making your questionnaire, when you are locating the scale, because once you have done it, you have no way of going back. Okay. So with this, we come to an end to tiered sample t-test. Okay. Now we move to two jumbo techniques which are known as factor analysis and regression. Are you aware of factor analysis? What do you mean by factor analysis? Any idea? What do we mean by factor analysis? Yes or no? When do we use a factor analysis? Quickly. See, whenever, huh?
No.
Yes?
No.
Okay. Factor analysis is basically a technique that we can use for when we are developing the questionnaire, when we are a lot of statements, we have collected a lot of statements, we have compiled it. Now we want to know if we can get out, if we can reduce. So factor analysis is known as a reduction technique, where we can, you know, do away with those statements which are not creating any significance in the response process, and they can be put out of the questionnaire. Or we want to understand what are the major output that we are getting to understand the data. Okay, so there are exploratory factor analysis, there is a principal factor analysis, there is a confirmatory factor analysis. Generally they go about same. Okay, but still you must know the concept. And again I'm telling you, everything is on internet. You can go and you can appreciate what is the difference between the two. So here we are going to cover principal component analysis, which is going to reduce a large set of variables into a smaller set of variables. Okay. So what happens here is, if you have a 7 and 8 questions for every statement, and you believe that you want to draw a new questionnaire out of it, which should have a lesser number of questions, then in that case we are using it. Okay. So generally the steps are this: you go to analyze, and then you can go to dimension reduction, and you can go to factor. So I'll just help you with it. I will do it in this thing. So you go to analyze, and you can see a dimension reduction, and you can go. Now you have to choose. Now again, remember, factor analysis has got an assumption that data should be above normal. There is a condition. Okay, it should be more. Number of variables into 3 times the data should be there. So if you have say 36 questions, so at least you should have more than 100, you know, responses to apply factor analysis. Okay, so we select it. So these are the statements on which I want to apply the factor analysis. Okay, so I'm going to select it all. So I do a control A, and then I remove them, which are not interval. Okay, and then I shift into the variable box. Okay, this is how I do it. Okay, now if I go back to my PPT, you can see here that I have just questions here, which we want to run the factor. Then we open the column of descriptives, and we give initial solution. We open the coefficient, we check KMO test, we produced anti-image, all this we have to check. Then in the second, we have to choose which method you want to go ahead with. So we'll do again for this R data sets. In the descriptive, we'll go coefficients, KMO, anti-image. Okay, we give, then we go to continue, we go to extraction. So we'll have to say principal components we are using, okay, based on eigenvalue 1, continue, rotation, you have to select varimax. What do you mean by a varimax or a promax? Varimax basically when you assume that the variables have enough and more, proximity among them, then you use the varimax. If you feel that the variables are not that related, the questions are not that related, then you use promax. But under normal conditions, we use a varimax type of a rotation only. Okay. Coefficient matrix, continue, options. Okay, exclude case wise. Okay. So now we do an OK. So now you can see it has given you some data. Okay. These are going to be the different tables which you will get, but you have to select only one table. Okay, how do we select it? So this is the data that you will get out of it, which is giving you the correlation because we have ticked. Now these are the factor extraction table. Now see, this is an eigenvalue table. Now this is very important. So this eigenvalue table is basically explaining you what? That you selected 34 variables, but out of that 34 variables, we were able to reduce them into 1, 2, 3, 4, 5, 6, 7, 8, 9 categories. So 34 variables is now reduced to 9 important factors. Isn't it wonderful? That means few of the statements can be either combined and few of the statements can be dropped. Okay. So this table is known as total variance explained. It is going to tell you how many factors would be made. And this table, which is the rotated component matrix, will be telling you what are those 9 factors. Which are those factors which are 9. Am I clear till now? Yes or no?
Yes, ma'am.
Yes. Okay, great. So we'll just go by it. So here is a little bit a smaller description. So I'm showing you this table that will help you to understand. So here, like for example, question number 1, question number 2, and question number 3. So anything 0.6 and above can be considered for first factor. So this is a table that is telling us that question number 1, question number 2, and question number 2, that is statement 1, statement 2, and statement 3, they make one factor. Now at the same time, you can see that question number 2, question number 3, so these are, this is one factor, this is the second factor, question number 4, 5, 6, because they have all high score, and question number 7, 8, 9, these are one factor. So in the example that we are taking, out of 9 statements, there we are getting 3 factors. Okay. So if we go to our analysis that we have got, our output that we have got, this is the table. Okay. This is the rotated component matrix. This is a rotated component matrix. So here we can see that a 0.94, 0.961, these are all above 0.7. And you can see below this, there are also these 12, 13, 14, 15, 16, 17, 18 number of statements, they form our factor 1. Then we go to factor 2. For the factor 2, we can see the statements which are CC25, CC26, CC27. Okay, these are the statements which will be factors in. So in this way, now what we are supposed to do, once we have identified which are the questions that can be grouped together, we try to understand the essence of the question and we try to keep a name of the factor. Okay?
I think ma'am has disconnected. I'll just try to call her. Yeah, we'll just wait for a minute or so. Ma'am is joining back. There is some technical error at her end. So let's wait.
Hello, ma'am. Megha, ma'am.
Yes, yes, yes.
Actually, there is a network outrage also in many areas today. The
Right.
network issues today in a
Yeah,
lot
I
of
just
areas.
spoke to her. Yeah, she's joining back. Yeah.
Okay.
Audible?
Yes, ma'am.
Okay. So these are three different kind of methods that we have learned today. You know, we have understood what. So basically, what I want to say you is that regression, factor, these are some multivariate techniques. Okay, multivariate techniques can use a wide variety of lot of variables. So regression can be a linear where you can whether you use one-on-one variable, or it can be a multivariate technique also. So the important thing is that SPSS is not that difficult. You don't have to get confused on which command to follow or how do we go about it. But it is very, very important for you to understand. Okay. So it is very, very important. So it is very, very important for you to understand that which method do we use and how do we use. Okay. So I'll just show you one more test which I have prepared, because why to even stop the process if we are back online. So I also want to teach you regression. Now, if you see the regression technique, regression and as by the chart that are independent should be interval scale use. So for regression that you use linear, okay, and you have both the data which is independent out of this and which is dependent out of this. Okay, this you can see here. Here we have selected price as dependent and income as independent. Okay, and once you press OK, this answer is going to come. Now this answer These are the 3 tables only which you are supposed to see. Now, how will you know which tables to see? You can always refer to IBMS cases or a layered version, which I was just I was explaining to you. We see how to interpret it. This is the data you're going to see. Now, what does the data mean? This data means that your independent. So in this, which one independent variable? Your independent variable is income. And second, the dependent variable is price. So according to this table, the income was 74% affecting your price. That means you can explain the 74% of changes due to income. You can that from income, but that is considerable. Now the second output is you have to see the level of significance. That is 000, which is 0.005 below, which is 0.00, which is below 0.005. That means yes, this is significantly affecting. So if even you will not get not significant here, then this adjusted R square will also reduce accordingly. Okay. So then you make the equation. Now if I tell you the equation that we follow, you must have read in your textbook, it might be. So if I just show you, equation is generally y is equal to a plus bx. Okay. So x is your independent variable, because you can also put it like this. Okay, this is the equation in the books of statistics. Equation you can derive from here. So here the constant is 0.8. So your dependent variable, the constant is 8287, and your income is 0.564, which is into income. So this is a linear regression relationship, which two things, they are correlated with each other. We are clear about it. But we want to know exactly that how much. We want to know the percentage. Under those conditions, we go by this analysis. Okay. So I hope we are clear with the regression as well. Yes, any issue? So analyze what is we follow. So we go to the dependent and independent. They should questions you want to ask? Hello.
Yes, ma'am.
Yes. So I think, Megha ma'am, I am done.
Yeah.
I will take a quick recap now before I finish the session.
Right, right.
Yeah. So basically, whenever we are dealing with SPSS or any other software, first we have to get our concepts of statistics all right. Okay. So let me tell you, SPSS is not only the tool that we use. There are a lot of tools nowadays which we use, and you can use any tool by checking its, like there is one more software called Jambori. Okay, some people use that software also. So there are a lot of softwares which will help you to do this basic calculation. Even advanced Excel allows you to do many basic calculations. Okay, first thing. The second thing is that get your concepts of research right. So the research concept will begin from the time you make your theoretical framework or the diagram from where we begin, because that is the starting point where we identify the variables on which we are going to do the research and the variables which we are not going to consider. Okay. Then once you have shortlisted the variables, you have to collect, you have to make it, what do we call it, known as operationalize, means you have to convert it into questions, because like a working condition is a variable, but there can be a set of 10 statements which can help me to understand what are, how do I measure the working statements. Now some researcher, he might have patented a set of 10 statements, some researchers, he might have used the 15 statements. It is completely on you whether you want to develop your instrument, depending on case to case basis. But it is always recommended that you try and choose a standardized questionnaire, okay, which somebody else has already developed, and the reliability and the validity is, tested. Generally, if you use your questionnaire, then in that case, you have to do a reliability and a validity test. Okay, there is a Cronbach alpha test, and there is a correlation test that you do to understand both the concepts. Now, when before even doing the reliability test, you have to take a very good look at the questionnaire that you are framing and the type and the scale that you will be using in order to capture the questionnaire. Okay. Once you have collected the questionnaire, then you put the data on Excel and then you transfer the data into the data view of the SPSS view. SPSS has two view, data view and variable view. Once you put the data into the data view, then you go to the variable view of SPSS and you define each of the variable for a better understanding. While defining of the variables, you really have to take care that the values or the labels have to be clearly defined and the scale has to be clearly defined, because these two things substantially affect the data analysis process in SPSS. And also, if you have a missing data, 99 or any other digit numeral, you can select in order to represent a missing data. So that whenever the processor of SPSS work, it will skip those data fields from the analysis and you will still get a genuine analysis. Never ever put the data from your side because it makes it biased. Okay, that is not a good practice as a researcher. Once you do that, then you see which are the variables you want to test and on which of the scales they have been measured, because the scaling of the variable will let you know that which are the tests that can be applied. Now, if you are doing, till the time you are doing a single variable test, you can use mean, mode, median, ANOVA, T. But whenever you are using two variables together, in such cases, again, refer to the chart that I just showed. You can get a book from Uma Sekran. Okay, it is on research method from the Wiley publication. This is the book from where I have picked up this table, and it is a very good book that explains the basic concepts of research. Okay. And then once you have decided upon the test which are to be applied, then you go ahead with your SPSS techniques. And for SPS techniques, all the information is given on the Google, on the IBM SPSS website, as well as the Liar. Screenshots have been given to help you to carry on a step-by-step analysis. And you will see a lot of tables are generated, but only the tables which these people, recommend, you only have to, pick up those tables and you have to make your decision making. I hope I am clear with that.
Yes,
Yes,
or
ma'am.
no?
Yes, yes, very
Yes.
much.
Yes. And the, and the processes that we have used, we have learned the techniques called ANOVA. We have learned test of normality. We have learned something about parametric or non-parametric test. We have learned factor analysis. We have learned paired sample t-test, independent sample t-test, and regression analysis. So apart from this, there is a Friedman, there is a Krusel-Wallis test, there is a Spearman correlation. Again, everything is there on internet, okay, on the Google sheet. Only you have to ensure that the concepts are right, the scaling is right, the the choice of the parametric and non-parametric test are right. If you do that, then your analysis will be 100% correct. Yes, any question?
Yes, participants, the platform is open for you all to ask questions. I think, ma'am, it's very much clear because you have explained us very much in step by step with very suitable examples. So I don't think
Yes.
so there would be any questions. And in between also, they have always cleared their doubts.
Yes. I have kept a dialogue kind of a thing open.
Right.
So I think, Megha ma'am, thank you so much for giving me this opportunity.
Yeah, ma'am, it's our duty to thank you for your time, for your experience to share with us, because the kind of rich experience that you have. But in spite of that, in a very lucid language, you have explained us, because these are the very technical terms. And till the time we don't see it online or we don't actually do it, it becomes very difficult for us to understand. So I really thank you from a bottom of my heart. And we will stay connected, ma'am, for further endeavors as well. Thank you so much.
Yes. Thank you, ma'am. And I would really request you to share me a feedback about what people felt. Okay.
Sure. Definitely, ma'am. Definitely.
Thank you so much, ma'am. Thank you so
ma'am.
much. Bye-bye. Bye-bye, everyone. Have a nice day.
Yeah, you too, ma'am.
Thank you.
Participants, as this is our last day of the workshop, I'll be sharing the feedback link shortly in the group. Moreover, I'll also be sharing one of the Google form link to you all, wherein the test, as we all said, and it was mentioned in the brochure, that at the end of the workshop, we will be having the test based on whatever that we have learned in past 7 days. So there will be 70 objective oriented questions. The link will be open for 2 hours, starting from 1 p.m. to 3 p.m. So you all are requested to fill in the details, and based on that only, whatever details that you fill up, we are going to mention it on the certificate as well. So be careful, check it twice and thrice, the name, the title that you will be writing onto it, your institution name and all, and accordingly that will be printed on certificate. Based on whatever marks scores that you get it, the grading will also be reflected on the certificate. So kindly make a note of it. And by 1 o'clock, I'll post the link into your WhatsApp group and we shall attend it. I hope there are
So,
no
ma'am,
queries.
exam is today itself, na?
Today itself from 1 o'clock to 3 o'clock.
Okay.
Any further queries? If not, then we'll wind up. Thank you so much for all the 7 days attending patiently, sincerely, and making it interactive. So we look forward, the group remains the same. And in case further, if we have any other workshop seminars, I'll be posting into the same group. Thank you so much.
Thank you.